Greetings and welcome, Mr. Waddy and my geometry friends are here in real life, and we're going to talk about this idea of using congruent triangles. So we have spent the last few sections talking about ways in which you could prove two triangles are congruent without having to show that every one of their pieces happens to be congruent to one another. But it turns out, because we've been able to prove triangles congruent using only 3 pieces of information, we can then determine the other missing components must also be congruent to one another. So here we go. Let's jump right in. It says, explain how you can use the given information to prove the hang gliders are congruent. All right, so let's see. Let's label our information. This isn't asking for a formal proof, so you guys can do it as so. So I've got angle 1 is congruent to angle 2. Let's see. Wait a minute. It looks like they labeled those. No, okay. I did do this wrong. Angle 1, they are literally talking about this angle and this angle. Yeah, okay, all right. So, it is a little bit more difficult, isn't it? So, what can I show as a result of that? Well, actually, let's finish labeling it. RTQ, so this angle is congruent to this angle. What else can I show? Now, this is a straight angle, and this angle in here is going to end up being congruent to that. Basically, these are a linear pair, these are a linear pair. By substitution, I could swap the measurement for 1 for 2, and because both of these angles are supplemental, what was that? The congruent supplements theorem? It's a rare one. We don't reference that very often. But because both of these angles are supplementary to the same angle, or 2 angles of the same measure, they are going to be congruent to each other. All right. Basically, imagine if angle 1 was 170 degrees, and angle 2 was 170 degrees. The only number I could add to 170 that equals 180 is 10. Both of those would have to be the same. All right. So that's congruent supplements theorem. What's another thing I could say about these triangles? All right, RT congruent to itself. And now I could say that triangle QRT, Ryan, is going to be congruent to triangle SRT. And how do I know these triangles are congruent? Nope. No. Angle side. Now notice, this problem didn't ask me to prove these triangles are congruent. But Ryan, it turns out that the only way I could prove these 2 segments were congruent was by first showing the triangles were congruent. And because those are the same, I can now say that their corresponding parts are the same. So I could say that QT is going to be congruent to ST by CPCTC. Let's actually write that out as well, just so that way, because yeah, and maybe it's a good idea when you guys are doing your homework or whatever to write it out until you know what it stands for, so that way you know what it stands for. So that's corresponding parts of congruent triangles are congruent. Yeah. I just jumped way too far. There we go. Sorry. Are congruent. All right. So, which I like to affectionately refer to as say, pay, C, T, C. All right. Question, comment, observation? All right. Let's take a look at this one. Ooh, a river crossing example. Lovely. Yeah, we should go on a field trip to a river. Is that what you guys are saying? Like, I can't really visualize. No, I would have to charge extra money for the Captain Wilderness fee. Ooh, wow, it'd be like the Hardy Boys. We'd solve this mystery using trigonometry. So, here we go, guys. We don't have enough time. All right, here it says, the following method can be used to find the distance across a river from point N to point P. All right, also, notice that the valuable distance across the river would be the one that's perpendicular to the shoreline rather than the diagonal. So there you go. So let's see. It says place a stake at K so that NK is perpendicular to NP. All right. So measure a right angle. Bam. Find the midpoint M. All right, gentlemen. I'm going to ask you to be quiet, please, because I think you're missing this. And there was worry that some of us might not remember all of these things, but it's really hard to remember if we don't hear it in the first place. So let's see. It says find the midpoint M. And let's see, because that's a midpoint, then by definition of midpoint, these are both congruent, right? What's another piece of information I could label here? Yeah, vertical angles theorem, right? Those two angles are going to be congruent. And now, how could I what? This would be, yeah, I'll label it right here. Angle NMP is going to be congruent to KML. All right, by vertical angles theorem. And now I could prove these two triangles are congruent. I guess I might as well use the same triangle names. NMP is going to be congruent to triangle, that is a better triangle, KML. How are those two triangles congruent? Right, so you guys have, whoa, man, oops. Wow, man, with the frame rate of my video, you definitely caught that. Someone's going to freeze frame it and make a meme. Uh-oh, embarrassing. I wrote in an illegal theorem real quick. Yeah, embarrassing. So, because these two triangles are congruent, how is that going to help me measure the distance across the river? Right. Yeah, that's an interesting point Ryan's mentioning. NP is congruent to KL or LK by CPCTC. And then I also technically know that NP is equal to KL, their measurements, by def of Cong. And then I could measure this length, and that should be the same as that length. Question, comment? No. So, or maybe I'll talk about that someday. But let's see. Let's do example 3. I don't think we'll have time. So we'll see. But oh, absolutely. 10 to the 24th planets in the universe. 10 to the 80th subatomic particles in the universe. Yeah. So anyways, let's take a look at this. Planning a proof involving pairs of triangles. Use the given information to write a... We're actually just going to, instead of writing a plan, we're just going to prove it. All right. So guys, here we go. So, statement, reason. So let's see, angle 1 congruent to angle 2, angle 3 congruent to angle 4. So we've got our given information that I can work with. Now notice this is what I'm trying to show. BCE, I'm trying to show this triangle is congruent to DCE. Now, I think I could incorporate these angles somehow. If I could deal with a larger triangle first. If I worked with this, I think I could prove the big triangle congruent to the big triangle first. Do you guys see what I'm going for here? Yeah, you think that's doable there? Wait a minute, what is going on? Here we go, there we go. I got my calendar notifications jumping up, blocking my screen. All right, and I got rid of my, there it is, there's my inkwell. All right, so let's try to prove these two purple triangles first, and then I think I'll be able to find information to prove those other triangles. So how could I prove those two purple triangles are congruent? I already have two angles. Yeah. So CA is congruent to itself. Reflexive. And now I could say, yeah, CDA is congruent to triangle CBA. There we go. By CPCTC. Nope, I lied. I'm a liar. Angle, side, angle. I don't know. So here's two angles and their side. Now, what other information can I get, gentlemen? How is that going to help me move towards proving these blue triangles? What other information does that help me get? Gentlemen, I'm going to ask again for you to just be quiet because we're trying to solve this problem together. Thank you. So let's see. I think I could then prove these are congruent. Do you agree? So I've got CD is congruent to CB. And those are both parts of those purple triangles. Those are even corresponding parts of those purple triangles. Like so. So that's true by CPC-TC. Now, what else can I go for here? Okay, so this entire angle, CDA, is CED? Can I prove that yet, though? We need your brain power here. So guys, I'm trying to prove BCE. Yeah, I'm definitely trying to prove these. These angles are unrelated to the purple triangles. Right now, for those... Aha! Guys, it's right here. These blue triangles, what do I got? I've got an angle and I've got a side. What other information can I show? Right, yeah, CE is congruent to itself. There it is. I was worried I was going to have to go through the big angles and then do angle addition and subtract, and it was going to be horrible. Let's see. So CE is congruent to CE by reflexive property. And now I've got enough information to prove those little triangles congruent. So this is actually an interesting problem. I had to prove another pair of triangles congruent, use some of their corresponding parts to then prove a final pair of triangles congruent to each other. This is a very much more difficult proof because it's kind of nested like that. And these two triangles are congruent by side angle side. All right. Let's see. Proving constructions. Yeah, let's take a look at example 4. Can I get a clean snapshot of this one? There we go. No, I'm screenshotting from my screen and pasting it up onto that screen is what I'm doing. All right, it says, write a proof to verify that the construction for copying an angle is valid. All right, so we've been doing this, but the question is it true? All right, is it true? All right, so I've got this information. Let's make a little proof here. So statement, reason. Let's see. So when I duplicate this, AB is going to be congruent to DE. And that's just the way that I swipe my arc. That's just going to be true by default. So that's going to be given. I think I usually do a capital G, don't I? I also would know that AC is congruent to DF. And actually, we technically even know that those are congruent to each other, but I'm not jumping the gun there. That's also given. What else do I have? That's what I'm trying to prove. I want to prove that these angles are congruent. But it turns out I actually know that by the way this arc swipes, that these sides are also congruent. EF is congruent to BC. And that allows me to prove these two triangles are congruent. Did they do the letters in the most convenient alphabetic order? I bet they did, right? ABC to DEF, yeah. Why are those triangles congruent? Yeah, sad, sad, sad. And because the triangles are congruent, I could now say that angle A is congruent to angle D. And why is that true? CPCTC. Corresponding parts of congruent triangles are congruent. All right, thanks, ladies and gentlemen. Have a great day.